so badly flawed that more testing and more evaluation of teachers will do nothing to correct the problem. Math is not taught very effectively. One teaches students to learn, one teaches students to understand, one teaches students how to practice intelligently, and when one tests for competence, which may mean giving the same test over and over. And one should teach so that the students begin to wonder and experiment. Very little of this is done in the education system now, except by very dedicated and skilled teachers. How do we teach math now? We teach children as if though they were robots. They just have to follow instructions faithfully. We have to give them a mindless dependence upon manipulators and calculators so they don't really have to understand what they're doing. And we further aggravate that problem by not explaining how things are done. And finally, we have low expectations. We give them partial credit for problems that are incorrect. We allow them to use crib sheets with formulas so they don't have to learn or understand these formulas. It is obvious why math is so badly flawed. Long subtraction is our first step in showing the state of mathematics. We show on the left a long subtraction problem where we have to cross out digits and rewrite group digits, really changing the content on the paper of the problem. It may not be so bad for just this isolated subtraction problem, but if this is part of a long division problem, we have lots of clutter that we're putting into our work. On the right-hand side, if we're using mental addition and recognizing that rather than borrowing from the top, we can add to the bottom, we find we can get a much cleaner answer. 8, subtract 9 from it, we borrow a 10 to make that 18. We get 9. Since we borrowed, we return that 10 in the 4 and make it a 5. Subtracting the 5 from the 7, we get 2. Since we didn't have to borrow, the 5 is going to stay the same in that next digit. Now, we subtract 5 from 14, we get 9, but since we had to borrow, we add that back into the 3, making the 3 a 4. We continue that, we're continuing borrowing, the 2 becomes a 3, and then the 1 becomes a 2. We get exactly the same answer with a much cleaner and nicer results. So what we find is that what's not emphasized is how we lay out the problem is going to reduce the amount of errors and make it easy to correct. This, I think, illustrates very nicely where something we could have corrected decades ago has continued to be taught in the same inefficient manner. Long multiplication is another illustration of where we've gone wrong in math. If we look at the left-hand side, when children multiply 2,000 by 2,500, they actually multiply by the zeros, rather than just copying the 2 zeros down. They claim they're using them to place the numbers in the right position. Then a new method has been used, which is called the lattice approach, which is supposed to reduce the errors made in multiplication. It might work well in a 3 by 3 operation, but is not very effective in a 5 by 5 multiplication. It turns out that my experience has shown the errors made in the addition of the partial results rather than in the multiplication itself. And then finally, we have a method which is a more proper method. When we're multiplying 2,000 by 2,500, we collect the zeros and count them. There are 5 of them. And then we multiply the 2 times the 25, which we can do in our heads. This gives us 50 times 10 to the 5th, and we collect the zeros again and get 10 to the 6th. Much nicer than writing out all 6 zeros. So we have seen that with multiplication, there are so many errors we make in terms of the way we teach and expect from the children that they become overwhelmed with the problem and never really learn to understand it. Long division brings everything together. To show the conventional way of doing division, it's too messy and too unorganized, particularly when one uses the lattice method to do the partial multiplications. Here I show if you're using mental arithmetic and you're using the techniques I showed you in subtraction, you can get a very clean presentation of the problem. Long division and long multiplication summarize everything that's been learned, and doing these number of these problems give the practice we need in order to understand and appreciate what we're doing, and giving it a chance to wonder. Again, we question why they teach math the way they do now. The argument that's usually given, we don't have enough time. When taught properly and effectively, there is more than enough time. I throw a few unanswered questions in terms of just showing the weaknesses in our math education. 0 is not nothing. It's a number before 1. This explains many of the properties of 0. What is a fraction? It's defined by the number in the numerator. 1/2, it takes 2 of them to make a whole. 1/5, it takes 5 of them to make a whole. Why do we invert fractions when we divide? It's because the way we define fractions and the way we define division. Why is the product of negative numbers positive? Again, we can do a similar proof in terms of why we invert fractions when we divide. And finally, many high school children, after they've taken geometry, still cannot tell you what a straight line or parallel line is. This observation and talking with children gives us a lot of insight to how effective teaching has been. Talking with teachers, many of the teachers teach according to the proper methods, but somehow that information doesn't get across. Those students who go on their own or under the direction of a parent or teacher will discover for themselves that which is not taught. They practice and they put in the necessary time to learn and to understand. State and federal government has shown little competence in designing the curriculum and measuring it. One cannot do well with a broken tool. Contact me. Go to my website, itmeansmath.com. You will see an alternative method for teaching. Maybe we can work together.